here the solution is 7/6, or 1 1/6. Nice thinking if you found this fraction. Basically, we're just going to evaluate our inverse function at x equals 2. So we just plug in the value of 2 in for x. So 2 plus 5 equals 7, and I still have 6 for my denominator. So 7/6, or 1 1/6. Now, there was another way to solve this problem. If we remember that the x and y coordinates switch for the inverse function, then we can make the y coordinate be 2. In other words, we know the input for the inverse function will be 2. This means that it must be a y value for the original function. So we could take our original function and let this output, or this y value, equal 2 and solve for x. Letting this f of x equal 2, we can now solve for x. We'll have 6x equal to 7, and then we'll divide both sides by positive 6 to get x equals 7/6. Since x is the input for the original function, we know this will be the output for our inverse function. Remember that the x and y coordinates will always switch for the function and its inverse. Now I know the second method is a lot longer for finding our answer, since all we really needed to do was plug in 2 into here. But it's worth conceptually noting so that way we can understand that the inverse and its function always have the x and y coordinates switched.